Good morning everybody. This video I want to explain to you the worksheet I asked you guys to do on blackbody radiation. The first page actually is pretty straightforward. You can take a look at the solution I posted online through the Blackboard. So basically the first page asks you to do is you can the y-axis is the energy output, and the x-axis is the different colors. They have different frequency, they have different wavelength. So whenever some color of light is higher in terms of energy output, that means you have more energy for that particular light. So I think you guys should be fine with this page. The next page, okay, as I explained from the last video, I want to explain one more time. Okay, when you read blackbody radiation curve, there are two things you need to pay attention to. The first thing is the maximum height or peak, so which is an indication of the star's energy output. So if you're looking at, if you look at the screen over here, you're looking at, okay, where the peak, okay, how high the peak is, or overall the curve, how high the overall curve is going to tell you the energy output. And the second thing is where the peak is located. It's going to tell you the star's temperature or the color of the star. Okay, so I'm going to go through these problems one by one. So if you look at figure 2a, okay, the first question is, which star gives off more red light? The answer is star A, is because if you look at the red, where the red is located along the x-axis, and then you look at the energy output. So A is higher than B, so that tells you A gives off more red light. 7, which star gives off more blue light? And then now you're looking at the blue light, okay, here, and then you're looking at how high each curve is. So A is much higher than B, so that means A gives off more blue light. Number 8, which star looks redder? So for a star looks redder or bluer, you're going to look at where the maximum is located. So for A, the maximum is located at blue end. For B, the maximum is located at red end. So which star looks redder? So B. And number 9, the student 2 is correct. Okay, so for 10, you're looking at figure 2b now. If you look at figure 2b, okay, figure 2b, you can take a look at, so you can see star A, actually overall the output of star A is higher than star C. However, these two stars, they're both, the peak, both are located at the same blue end. Okay, so that means, okay, they are going to have, if you answer question number 10, they're going to have the same peak wavelength. If they have the same peak wavelength, they're going to have the same surface temperature. And then both, they are going to look blue, so neither of them looks red. Both look blue because A, overall the curve is higher than C, so then A has greater energy output. Number 11, how much star C be different from star A to account for the difference in energy output? Because we know that both A and C, they have the same temperature, but A has much energy output than C, so that means it tells you A must be bigger than C. So star C is smaller than star A. So think about what we learned about luminosity or total energy output as a function of radius as well as temperature. Think about the worksheet we did actually about luminosity, size, and temperature. So the bigger the size, the bigger the luminosity. The higher the temperature, the higher luminosity. But for this case, both A and C, they have the same temperature, but A has much higher luminosity than C, so that tells you A has to be greater than C. if you look at figure 2C here, figure 2C, these two curves, okay, they have the peak height, but for A, the peak is located at the blue end. For D, the peak is located at the red end. So that's the difference. That's the difference between A and D. So in order to answer the question for 13 and 15, so for each star, describe its color as either reddish or bluish. Star A should be bluish because the peak of star A is located at blue end. Star D is reddish because the peak of star D is located at red end, as I showed you from this diagram here. Okay, again, for color or temperature, you look where the peak is located. Okay, so for 14, which star has the greater surface temperature? Again, think about luminosity as a function of radius and temperature. Okay, when the radius is bigger, the luminosity is bigger. When the temperature is higher, luminosity is higher. So in order to answer question number 14, which star has the greater surface temperature? And 15, okay. So for 14, because A is more bluish, so we know the blue light actually has higher frequency, shorter wavelength, so then the star is actually hotter. Okay, so A is hotter than D, but they both have the same energy output. That tells you A must be smaller and D must be larger. So that will be the answer for number 15. Okay, I hope this helps you to understand this worksheet better. If you still have questions, please let me know.